Hey guys, in this video, we'll be looking at cert insert position. This is problem number 35 on LeetCode. It is of easy difficulty. The idea of this problem is to insert a target value within a given array of nums. Let's take an example. The first example here has an array of integers. Let me paste that here and a target value of 5. So in this problem, we need to write a function to determine if this target is actually present within the nums array. If it is present, we just need to return the index of the found element. Otherwise, let me take another example here. So there is a slight modification that we need to be handling. So this variant is I have a target of 2. Within this array, we cannot find a target of 2. So if we cannot find the exact value, all we need to do is give out the insert position. So since this is like a sorted array, we need to be able to figure out that 2 needs to come after 1. So the output of this, the function's output when we feed the nums array and the target should be 1, as you can see here in the example 2. So again, just to reiterate, first thing is if we find a target within the nums array, you just return it. If you do not find the exact number, the target number within the nums array, you just need to return its insert position based on the value, since we already know that the array is in ascending order. Okay, let's also take a look at the constraints. The nums length is always in between 1 and 10 power 4. That means we don't need to check for the emptiness check of the nums array. So it's at least going to have one element within the nums array. Okay, and nums of I could have negative numbers as well as positive numbers. It's always going to have an integer as in each position of the array. The third thing is nums contains distinct values and values sorted in ascending order. What that means is we don't need to worry about duplicate elements within the array, right? And the fourth constraint is um, the target the target number is anywhere in between minus 10 power 4 to 10 power 4. Okay, so these are the four constraints that we have. If you look at the problem statement carefully, it's mentioned that all the integers are distinct. Return the target value if found. If not, return the index where it would be if it were inserted in the order. And the most important thing to be highlighted here is you must write this algorithm within O log n runtime complexity. What this means is you shouldn't be iterating over the entire array within a linear complex time complexity. Instead, you need to be able to solve this in a logarithmic time complexity. So this is the hint that we have. So whenever you are asked to solve something in a logarithmic time complexity, and you're also given an array of numbers which are in sorted uh, order, you immediately know that you need to solve this using binary search. So binary search is an algorithm which lets you process the numbers or an array uh, with basically two pointers, a start pointer and an end pointer, and you continuously calculate the mid of the start and end pointer, and based on the target that you are trying to find, you are going to either move the end pointer or the start pointer to zero down on the actual target. So this is faster than going through each and every element within the ascending order array. To explain that in a better way, I'm going to use this example. So I have a nums array of 1, 3, 5, 6, and my target is 5. Now I'm going to start off with my start index as 0 and my end index as nums.length minus 1. So first one is my start index is pointing to the first element of the array. My end index is pointing to the last most element of the array. Okay, and then now what I'm going to do is I'm going to have my while loop running. So this is continuously going to run. Um, while the condition start is always less than or equal to end. And then I'm going to be I'm going to calculate a midpoint for this array. That's going to be uh, math.floor of start plus end, start plus end by 2. So this is going to give me the midpoint of start and end index. And then if it's going to have a decimal point, I'm just zeroing it down to the floor, math.floor. So that means if it's like 1.5, my mid will be index number 1. All right, so this is how I calculate my mid. Once I know my mid, I'm going to be looking at my nums of mid value if it is equal to the target value. If it is equal to target value, then there's nothing to do. We just need to return the mid, right? Because that is the whole point of zeroing down on the target value. So we have already found the target, so you just return the mid. That is the current index where you found the target value. Otherwise, you check if nums of mid is greater than the target, and then there's another else case, which is if nums of mid is less than the target. If the nums dot mid is greater than the target, that means your midpoint is high, still at the higher end of the target, right? So in this example, if you see 0, 1, 2, 3, so our mid will be 0 plus 3 by 2, which is 1.5. And then when I do a math.floor on this, it will give me 1. Okay. And then if you look at the midpoint, nums of 1, which is 3, right? Nums of 1 is 3. Nums of mid, which is nums of 1, which is 3. And the target here is 5. So nums of mid is actually less than the target. So it will go into the else case. If nums of mid is less than the target, I need to move my start pointer to the mid, right? So that will be start equal to, I need to increment my mid basically. Start equal to mid plus 1. Otherwise, if my nums of mid is greater than the target, I need to reduce my mid to, that is end, to mid minus 1, right? So previously my start pointer and end pointer were here. After calculating the mid and figuring out that it is my mid, nums of mid is less than the target, I am immediately going to move my, uh, let me check, I'm immediately going to move my start pointer to index number 1, right? And then I'm again going to calculate my start plus end by 2, which is my, in this case, it will be 1 plus 0, 1, 2, 3, right? 1 plus 3 by 2, which is 1 plus 3 by 2, 4 by 2. I'm going to get a new, let me copy all of this so that in the second iteration, my start will be, okay, my start will be at 1. My end is going to remain the same. The way I calculate the mid is 1 plus 3 by 2, uh, which is math.floor of 2, which will be 2, right? Now, I'm going to check if nums of mid is equal to target, right? Nums of mid is 0, 1, 2. Nums of 2 is 5 is equal to target, which is the case. Then I'm just going to return my mid, which is 2. That's how we are going to end up with the output of 2 in the first example. Okay, I hope this is clear. If you take another example of 1, 3, 5, 6 with the target 2, let me write down those steps again here. Example 2, I'll have my start and end pointing to the first and last index as usual. And then I'm going to be calculating the mid based on the indexes. Mid will be 1.5 again, since it's the same array. 1.5 and math.floor will be 1. In this case, my target which is 2. I'm going to check if nums of 1, 3 is equal to 2 or not. It's not the case. So my nums of mid is actually greater than the target. So I know that my end pointer should be moved. So it's going to end up on the same index as. So previously my mid was at index number 1. Now I'm going to change my index to mid minus 1. Okay, so both my start pointer and end pointer are on the same level. Since my while loop condition has start less than or equal to end, so this is still true. What will happen now is it's going to calculate a new mid, right? New mid is 0 plus 0 by 2, which is 0. My mid will be 0 now. Nums of mid, which is 1, I'm going to check if it is equal to the target. So it's not equal to the target. 1 is less than the target. So it's going to go into the else condition. And my start is going to be incremented to mid plus 1, which is 0 plus 1. That is 1. Okay. At this point, my end is at 0 and my start is at 1. What that means is this condition start less than or equal to end is no longer true. So that's going to break my while loop. So all I need to return now is my start pointer. So that will be my insert position. Okay. And if you check the order in which 2 can fit into this array, it's going to be at the index number 1, which is the case here, right? Because we have 0 plus 1, which is 1. And if you look at this visually, this array, 2 will come after 1 at index number 1. So that will be my index position. So that is how you solve this problem. Right now, I'm just going to copy all of the pseudocode that I've written here into the function, and then I'll be removing um, certain things. So I'll just add let start equal to 0, let end equal to nums.length minus 1, and I'll get rid of all of this. Okay, so if you look at it, we have a start pointer, end pointer, a while loop, with all the calculation of mid pointer logic, and also the checks if it is greater than, equal to, or less than the target, and then finally we return the start pointer. Okay, now let me go ahead and run this solution. All right, as you can see, it has worked for all the 3 cases. Let me go through over the first one. So here we found 5, so that our output is 5. In the second case, our insert position is 1, since we couldn't find 2 within this array. Likewise, for target 7, our position will be 0, 1, 2, 3, and 4, which is the last position of the nums array. So I think our solution looks good. I'm going to go ahead and submit this for all the test cases. All right, so our solution is accepted now, and this is how you're going to solve search insert position. This is a very important concept to learn, especially the binary search. It's going to come in very handy when you're solving trees and other search operations in a logarithmic time complexity. I hope you've learned something from this video. If you've liked this video and got something out of it, please give it a like, subscribe to my channel, and I'm going to be posting more such tutorials in JavaScript. So I'll be eventually solving medium difficulty problems. But yeah, if you have any questions, just drop your questions within the comment section. I'll be happy to answer them. Thanks again for watching. I'll see you in the next tutorials.